Decentralized technology has received a lot of interesting criticism over the years. Things like Bitcoin and all those cryptocurrencies often get mixed in with the technology because they're all based on that foundation of blockchain. Which is pretty good because with the blockchain technology, you're essentially distributing a spreadsheet across all a variety of computers, and then you're running bit randomizers to be able to find a match for a SHA based on a consensus algorithm. That was one of the first original consensus algorithms you've probably heard about Bitcoin. The challenge is that it requires a lot of compute to come up with a candidate hash that will match the requirements of the consensus. Through a series of transactions, you will be able to take the previously agreed upon hash and then generate combine that with the list of transactions, and then you have to generate a random ID that then you run a hash over that algorithm to create something that matches the consensus requirement. Usually it's like a number of digits that match 0 in the hash or something like that. Then when a candidate is found, it can be propagated through the network and everyone validates it, and then that is marked as the block of transactions is written in stone at that point. And then you can continue on to the next block of transactions. Even while everyone is searching for the hash that matches, you can continuously add more transactions into the ledger. This turns out to be a really simple use case. Yes, let's do it for a distributed ledger, a spreadsheet type scenario. And you can put currency in that situation. And that is one of the first widespread uses of decentralized technology. But it goes beyond that. There's more use cases and more capability. We haven't really explored all the capabilities that this technology has to offer us. Decentralized technology has a lot of inherent capabilities that bring with it some algorithms and architecture patterns that are useful in engineering today. Even though we can build on top of the existing entire blockchain type situations, we don't have to. We can take bits and pieces from that architecture and implement them into our own products. So if we're thinking about the technology, blockchain and consensus, these concepts are used in many scenarios, even with the idea of consensus is important for distributed applications. When you have applications across multiple geographies, you need a way for them to synchronize, and they need to have a rule of conversation that allows them to agree upon the delta of data. This is very commonly used in databases and service discovery mechanisms where applications come and go in a scaling up and scaling down scenario. You can go a step further and implement that concept into, say, your data records in a database for all the rows in a table. Each row can have an additional column called a signature row that signs data from the previous signature along with the data in the row that is all that, like say the row is like a user, right? Their first name, last name, and email address. And then the previous row had a signature, but you can also apply that signature into the next row, which allows you to have this chain of auditability. As new rows are added, you can have a sequence of order, and it's tamper-proof essentially. Well, I mean, you can go in and make some changes. However, you're going to have a much harder time coming up with the correct data that matches the signature requirement without breaking the chain. And you will have this tamper-resistant and auditable and traceable capabilities. So there's a lot of like good architecture concepts that are baked into blockchain and distributed technologies that we see in common scenarios for all those cryptocurrencies. The idea behind decentralized technologies is it brings with it a lot of interesting technologies and capabilities that we can use every day. We cannot use it every day. What am I talking about? There are large companies that do believe in this technology, like IBM here. They have a product called Hyperledger, which is very powerful, and they believe that it will bring a lot of fantastic use cases for corporations. Being behind the core technology of having a distributed spreadsheet that is auditable and security and tamper resistant, that kind of capability is actually pretty attractive to most businesses, where it's very critical that not only do we have a high durability of our data that we're keeping records of, we also want to make sure there's no accidents or mistakes. But what's actually funny, if there is an accident and it was inputted data, that data will be forever burned in and there's no unwinding of it typically. Of course, there are ways to go about unwinding it, but that kind of goes a little bit against the practices of having a set in stone ledger that is not changeable. IBM has made a big investment in blockchain technology. They've created something called Hyperledger. This is an open source blockchain platform technology, and they've even gone and built something called Hyperledger Fabric. Taking a look here, there are two different variations of Hyperledger. One is is the open source framework for distributed ledgers, right? So you're going to have a spreadsheet where you're going to record activities in a column for each row, and then the blockchain is going to be responsible for replicating that data across large amounts of computers and then verifying transactions using a consensus algorithm. Where Hyperledger Fabric looks like it's more of a platform, so they host the servers. We'd have to look into it a little more because it's more of a centralized situation if that's the case. The idea is, though, blockchain is fairly hard to get up and running. So if you can start with IBM's system and their platform, you'll be able to start building things like smart contracts that can live on top of the ledger. So you can run bits of logic that have outputs in the end result. With Hyperledger Fabric, it looks like just on top of the basic Hyperledger distributed ledger. Fabric brings with it some permissions capabilities. Oh, you can expose only certain kinds of transactions if you want. So some data is public and some data is private. That's kind of neat. They have some sort of a pluggable architecture, which means that you probably can bring some code that lives within the chain itself. And I'd say the biggest benefit in general is the easy getting started. Ooh, neat, check this out. The entire fabric itself is open source. And it's 18.4 million lines of code? That's a little bit much. That's just a bit much, I would say. I don't know, I wouldn't call that like a badge there. That's a detractor for me. In the industry, blockchain is really useful because you can use it for a lot of variety of things. We're going to check out some of those use cases here really quick. For example, cross-border trading with a public ledger, you'll be able to see what that transaction entails, and you will have a full record of it. Let's take a look at some of the real-world use cases that blockchain brings with it. Because there are some good ones. There's some really good ones. There's some actual legitimate use cases that do make things a lot more simple, a lot more streamlined, because it brings with it sort of an open source approach on how we interact across various products and exchanges. From a logistics perspective, you have the product itself. So in this case, like the coffee beans, right? And you have a shipment of those coffee beans, and you want to be able to track all the data about those coffee beans themselves. The transportation section, even going all the way back to the harvest date till it gets packaged. And that whole thing can be tracked, and that is tracked today, and that's usually done in traditional databases. So why would you need a blockchain for that? I guess you don't really, but the idea behind blockchain is it will give you a little bit more extra resilience, right? Because you have that distributed computing, data is going to be there, and you can rely on it even if systems fail, and that ledger over time will continue to grow, and you'll have a full traceback capability. You'll even be able to tell if someone attempted to tamper. Even if someone succeeded, you will have evidence of it. Would you though? Would you? Well, let's think about that really quick. If you wanted to tamper a blockchain, it would be really hard to do something pretty far back in the past, because as time goes on, every single record from previous change is stored. So as you're piling on more, you'll have to compute a matching randomized amount of digits that will work for each of those blocks. So that would be a lot of compute. You could do it, but you would have to have a lot of compute to make that possible. You could find solutions that would allow you to modify a point in that ledger, recompute the hash for the block, and then do that for all the other blocks going forward. And if you're able to get the consensus algorithm to take that modification, then you've done it. You win. You modified the chain. It can get really expensive though, depending on which consensus algorithm you're using. So I would call that pretty tamper resistant. Blockchain does have like a foundational use case capability that it just kind of everyone would tip. I mean, it's a ledger. It's essentially a distributed ledger. So all the things that you normally use a ledger for, they're actually all fantastic use cases for a blockchain itself, because it just brings extra security along with it. So anything that would involve a ledger, such as logistics, transportation, shipping, and finances, documents like titles and deeds, property ownership changes over time, leases and other things can go on top of that for documents of record. All these things could be blockchain ledgers entries. The ones listed here on Hyperledger, like shipping and shopping at the Home Depot. We've got first of a kind blockchain platform for transferring bank guarantee processes, more guaranteed than usual. It's not 100% guaranteed, but it's very likely guaranteed. Ooh, multi-cloud. Oh yeah, okay, that kind of makes sense. So if you want to reduce, so say you're a business and you have a high compute load requirement, and uptime and data retention is of the utmost importance, and you don't want to have this vector of attack by being isolated in a single cloud vendor. You could use all multi-cloud capabilities. You can use Google, Microsoft, and Amazon. Deploy your ledger across all their servers, lease their compute, and now even if one of those clouds goes down, you're still secure, you're safe because you've got the data copied in different cloud providers. Decentralized technology brings with it more than just a distributed ledger. It can also be used to compute based on they call them smart contracts. You may have heard of a programming language called Solidity. This is a programming language that's based in ECMAScript that allows you to program on the blockchain. Essentially, you'll be able to execute contracts based on addresses. When you execute these addresses, you'll be able to invoke a certain amount of functions based on what's written in the code. This is powerful from a reliability perspective because through distributed compute, you will almost certainly have a system that's up somewhere that will be able to begin processing your transaction. Due to the nature of the blockchain and its consensus algorithm, typically you'll find it might not be super fast. It doesn't need to be super fast in many of the cases because what you're looking for is that reliability and the insurance of that data being stored. A smart contract looks like regular code for the most part. You can define classes and subset of functions and methods here that allow you to execute certain tasks. In order to call these functions, you'll provide the address and the function name and the data that you want to be applied to it. That will get transferred along with the ledger, and then the ending result output gets appended as well. So you have an end-to-end traceability, essentially kind of like server logs, except those logs are distributed across the ledger, and the compute is also verified across multiple systems, which is kind of cool because there's not really many existing technologies today that will execute the same code more than once on multiple machines and then validate that the output and input are matching. So we can see that's pretty powerful because if we really want to make sure that our data is safe and secure, this is a really good way to go about getting that data into the system. The drawback though is it's slow. it's pretty slow, but that could be okay. There are things like that don't need to be super fast. Many transaction varieties, if you're looking at like if you do even a wire transfer or some sort of bank transaction, those can even be slow anyway. So this isn't any much different in the change of speed from that perspective. And there's even new blockchains and consensus algorithms that are pretty dang fast. We'll take a look at some of those as well. Distributed apps are still an up and coming way of building applications on the web. We can compare a lot of the options for public blockchains that make it really easy for us to build distributed apps. As developers, we have a choice of a variety. There's more than I have listed here on the screen. Things to consider when you're choosing your blockchain, your public blockchain, or what language you're going to be running. Lua is pretty great. It's an easy entry point. A lot of game engines will actually use Lua to allow developers to make plugins. That's because Lua is super duper fast. It's efficient, has a low memory footprint, and it's also pretty easy to understand syntax. If you're choosing something that needs to be you got to make sure that it's really powerful, and also it's got a compiler that can take care of business. Rust is a fantastic option. With Rust, there's a barrier to entry about learning how to interact with the compiler as you write code because it's a slightly different way of programming. However, what comes out at the end is a binary that's memory safe, which is critically important especially if you're running this across a lot of servers. But it's also super duper fast. That efficiency is critical because if you need to run the same application to validate the input and output on either side, you're going to need something that's efficient because you're running it multiple times on a lot of systems. From an attractive, I would say I would be more attracted to something that has a Rust in it as a way to move forward if you're making a decision about where to start building your distributed application. Taking a quick look here, building a distributed app with Rust looks like it's fairly straightforward, and the common pattern does not look like you can import too many libraries because I saw on this page, oh wait, hold on, wait, there's a word here that is, I don't, if you see a word like this, it says unsafe, that seems like a danger zone, doesn't it? But it seems like it's required because it is a entry point for the data that's a generic byte array for all the input data that's going to be used to invoke your application and specific methods on it. So it looks like we have the program ID, which is probably the smart contract ID, right? And then you've got the accounts, which is going to be the business entity or the user who owns that program, that smart contract. And that account ID will be the one that's going to be responsible for paying the network for the compute time. And then we have our instructions data, which is probably something like add 1 to this row, store this data over here. I see. So in order to get this to work correctly in a consistent manner, consistency is key because this is a consensus algorithm network, right? So we need to make sure that the input data and the output data conforms to a really strict format. It's got to be strict. Okay. So it's because of this restrictions and the strictness, we have limited access. We can't do anything that will create non-determinism. And what would be more than non-deterministic than a random function? Anything that's asynchronous. Okay, so it needs to be single-threaded. We can't do anything in parallel. No print. Wait, that's the thing I use the most for debugging. It looks like they have logger helpers. Okay. Oh, nice. Okay, it's really easy. Just an MSG explanation point. It's a nice little macro for us. Decentralized technology such as blockchain can be very beneficial and powerful to end users. End users like you and me every day that we are on the internet doing a thing, browsing social media or making a post somewhere. That data is centralized in those large corporate tower buildings. Social media platforms like YouTube, Instagram, Twitter, Facebook, Reddit. Reddit counts as a social media platform, I'd say. Wait, isn't Twitter called X? See, that's the thing. It's the X or Twitter, I guess we'll just call it this site for now. From an end user perspective, those corporations own your data. They're able to attract the currency of attention onto their platform and then sell advertisers opportunities to come in and provide some face time. But they use your data to do that and they profit from it. One of the ideas behind central tech is that those corporations can use their centralized technology to profit from it. But with a decentralized technology, it's possible that you as an end user can own that data yourself and then profit, kind of like a co-op. Why hasn't something like that taken off yet? I know there's attempts and there's things that are like it today. Oh, like this one. Mastodon. It looks like we're still at the beginning of the decentralized app and social media platforms that leverage this technology. So it says here that we can stay in control of our own timeline, basically what we're consuming, what we're seeing that the internet has posted on the Mastodon platform. And no algorithms. Well, I mean, I don't know about that. There's some algorithm involved there, but the no ads is nice. That's pretty cool. All right, this is pretty neat with the idea that it is decentralized as a communication platform. They're using that ledger technology distributed across many servers all over the world. This brings with it an inherent capability that what you're saying is going to be able to be stored and kept forever, which is nice from like hey, what about like those government entities or even a corporation that could do some sort of censoring of the data. We also see here that it's open source, right? That's great because now we can see all the code that goes involved. That's where the algorithm is, right? There's definitely an algorithm involved here, but we get to read it. It's open source. Also, it looks like your attention, which is the currency of these social media platforms, is your attention. It's not for sale on Mastodon. Okay, we see here that Mastodon really is sort of a mirror of what Twitter was, with some exclusions of that centralization. So no ads or hidden algorithms behind the scene. But there is moderation. It says, well, moderation, fully functional microblogging service. And if there's moderation, that means there is some censorship happening, even if it is a community driven. There are some benefits to that, right? Because you'll be able to participate in a group social environment that is, positive and moving forward with pretty cool conversations that are more productive in this case. Beside all those cryptocurrencies which come with it, these stigmas, decentralized technology is actually pretty powerful. We've been able to develop and take that architecture from what blockchain has given us and enhance existing needs for security and system stability. What's great is that those cryptocurrencies like Bitcoin, for example, they have brought with it the set of technologies that are required to generate a consensus across a large amount of servers. And we were able to innovate on top of that, creating new and more powerful consensus algorithms. So from a human knowledge perspective and a foundation of making better architecture and better software, it has made this improvement. We have been able to move forward and create new and better technologies. These are real-world implementations of distributed compute capabilities. So we've found ways to reduce our cost with compute that runs across a large number of systems. And we've developed a method of trust that can operate in a public environment that allows code to be executed in such a way that we can trust it. And it is even more trustworthy than what's happening behind the scenes on those servers. Who knows what's happening on those servers over there? We don't know. Those corporations keeping all those server secrets. We haven't met the finale of this technology yet. There's still more innovation that we can have, more ways to improve our consensus approaches, and new use cases and technologies that have yet to even catch on. One of my favorite approaches is just keeping a digital record of all of the titles and other documents like state and government official identifications, other kinds of certificates like birth certificates, and other kinds of systems of record that have yet to be digitized would benefit by leapfrogging directly to distributed decentralized technology.